Now, we have some other features that are built into this besides just simply creating scatter plots for the levels of these three basic measures. You have interactive plots. Take a little getting used to, but what you can do is you can inspect individual rules that appear in the plot by selecting them and clicking the inspect button. You can inspect sets of rules by lassoing a particular region and clicking inspect. You can zoom in or out. You can filter. Not sure we'll be able to do that. Let's give this a try. This is a little tricky. Okay, so note all we're doing to invoke the interactive feature, we're still just using the generic plot. All we're doing to invoke the interactive feature is just setting the value of the interactive argument to true. Let's try inspect. Okay, so I'll try and lasso that one. I did by you click when you click twice and it creates a rectangle. First click is bottom right, second one's top left. Every plotted object within that is then selected. And if we say inspect, okay, so we grab that rule by highlighting it. So we can inspect one rule if we want, and that was when people buy liquor and red blush wine, they buy beer. What a surprise. Very high confidence level. And lift is a relative measure, so we really don't know what a lift of 11 means unless we can see the whole range. But gosh, I could have told them that. Okay, what else can we do? We can you can inspect a whole set if you wanted to. There's nothing in that. Let's try the zoom. So I'm going to zoom in here. Let's make this bigger so we can. Let's zoom in on this set here. Okay, so now we just selected a small portion, a small area of all the rules. This can be very useful when you have a large number of rules. And we can inspect particular rules if we wanted to, or sets of them. So we selected those three. And so you get the idea. You get highly summarized relations of the entire rule base within these measures, support, confidence, and list, and then you can see all of the relations, but you can zoom in and catch just particular ones. Okay, let's go back now back over here to Zhao's material, and he's got some visualization rules too. Actually, these numbers here, figure 9.1, 9.2, 9.3, I got that right out of his book, and actually they're not correct. So let's see what this offers up. Here's one. We just say plot rules all, and what does that do? That gives us, yes, we do have it. Okay, so I was fine. Let's try that again. Let's inspect them. Okay, so that's our original Titanic set of 27 rules. And let me clear all this. Sometimes these interactive functions can, interactive plots can interfere with each other. Okay, so now we'll try it again. So we have the original 27 rules. Okay, there we go. So we get a scatter plot. Okay, we saw this already. We can group it if you use method equals grouped. Okay, here's kind of an interesting one where we get a bubble plot. So we're seeing here where on the left-hand side we have class, age, whether they survived. This is the original set of 27 rules. So whatever was on the left-hand side of those is plotted along this horizontal axis, and whatever was on the right-hand side, which was their gender, whether they survived, and their age, are plotted here, and the size of the bubble indicates the level of support. So the intersection gives you the combination of the left hand and the right hand. For example, this one here with the big bubble indicates the highest support among those 27 rules. The highest support was for where on the left-hand side it was first class. If they were first class, in their age, then they were adults. If they were first class and they survived, then if they're first class, then their age was adult. And the color is lift. So the darker are the higher lifts. So this would indicate that this one is very dark. This would indicate that if they were third class, or said a different way, if they did not survive, no, that's correct. If they were third class, that greatly increased the chances that they did not survive. There was a high degree of lift between the rule where on the left-hand side you just had them being in the third class, and on the right-hand side they did not survive. Okay, so this is kind of a variant of a bubble plot, if you're familiar with that. Let's see what else we have. So here's a graph, and this one is not clear at all. Okay, where the arrow is a rule base. Okay, so 27 rules. On the left-hand side, third class, male, adult, they probably did not survive. Kind of interesting, a little confusing, but interesting nevertheless, because you have so many different combinations. All of these arrows point to sex being male on the right-hand side. Where survived equals yes. Let's see if we can just find for a predicted. I don't see it. The numbers question here: what were the +1, +2, etc. in the left-hand side of the bubble plot? I don't know. I would guess it was just the frequency, but I don't know. If you send me an email, I'll try and look it up. In this plot, we also have some information on the width of the arrow. Width indicates support, and the darker arrows mean higher lift. Okay, let's see what else we have. Clear this. Another graph. Same sort of arrangement where the arrow indicates the base of the arrow is left hand and the head of the arrow is right hand, and we have the darker means more lift, lighter means less lift. The size of the bubble is the level of support. Okay, here's one more. And it's not giving me a read. Let me clear this to make sure. These are this is a parallel coordinates plot. Give me a chance to look in the paper, which I have here, to interpret this one, and we'll look at some other ones as well next time. Actually, I think the arulesViz package is quite interesting because there's a lot of information that you can get out of looking at plots, especially if you have a large data set. But I need to read this up before I can talk about this. We'll also look at some other specific applications in other domains. And so my suggestion would be to read that chapter and give a try at the exercise, and we'll look at them again next time as well.